So welcome to my presentation. It is titled Building Bridges While Walking on Them. I'm aware that I have the last slot for today, and the next event is actually cocktail party, so try not to bore you and not to take too lot of your time. I'm also aware that this title is a bit, let's say, pretentious, so I figured another one, which is a subtitle, and it's called How We Learn to Stop Worrying and That Everything Old is New Again. So, you might be asking yourselves, first of all, who am I and why should you listen to me? So, my name is Mladen Srdic. I've been in SevenBridges for more than 4 years now. Like most of you, I'm a software developer, software engineer. I joined SevenBridges in 2012, and I had the opportunity to work on a lot of different services, from authentication, authorization, streaming genomic data, orchestration, scheduling, and so on. And after some time, they came to me, and because I never create any bugs in production, just pure handcrafted code, they came to me and they told me listen, Mladen, you're so cool, so you're doing everything well. Do you want to be an engineering lead? So please forget everything that you learned so far and start doing this other thing you know nothing about. And because I love software engineering, I said yes. So after 2 years as an engineering lead and leading a team, I apparently did a good job there as well. And I got to a position of director of engineering. And it's been 3 or 4 months there. And I can't really tell you how it feels like, but I guess that the feeling is something like this. Those are the other engineering leads in the background. So I'll let it play again. Yeah. Okay. So the second obvious question for you who don't know is, what is SevenBridges? So this talk will not be concretely about platform and the business of platform, but the shortest elevator pitch that I can give to you is probably this. So SevenBridges provides the software platform that makes the analysis of and collaboration on population scale genomics data possible. The accent of this, let's say, elevator pitch is the population scale genomics. Bioinformatics and biologists can do it themselves, but there is a deluge of data that needs to be processed. And a need for platform arose in the last 5 or 6 years, and SevenBridges is one of the few platforms in the world, and judging by some of the comments, probably the best platform currently. I had to say that. More about SevenBridges. So it was founded in 2009 in Cambridge, Massachusetts. It has 2 founders, Denis Kural and Igor Bogicevic, and because the business is in Cambridge, soon enough in 2010, we formed an engineering team in Belgrade. After that, we scattered across the world to San Francisco and London, and a few months ago, we opened our first offices in Istanbul and Ankara. Also, SevenBridges powers some of the most innovative organizations in the world. One of the first national programs we got was the National Cancer Institute. We made the Cancer Genomics Cloud. We also have our London team works with Genomics England, which has a plan to actually sequence 100,000 genomes. Also, there is a national program, Million Veterans Project, which is an effort by US government to sequence and actually gather as much as possible medical data on American veterans. And also we have a collaboration with the Children's Hospital of Philadelphia. So let's go on. And the third question is probably why. And this is a twofold question. So the first answer is pretty easy, and I'm gonna probably risk sounding pretentious again, but this is important. This is something that is world-changing, and the precision medicine has a lot of promises and a lot of benefits for humankind. it already has a real impact. It's not just something that might be useful. People are already using findings from precision medicine to cure certain variants of cancer and so on, or even some genetic diseases and so on. The other part of the answer is this. So I'm not sure how well you can see the graph, but on the horizontal axis, you can see like years from 2000 and 2055. Can you see it at the back? Is it visible? So I will describe it a bit. So on the horizontal axis, it's just a standard time axis, 2000, 2025 at the end. On the left side, my left side and your left side, there is an axis which is cumulative number of sequenced human genomes, and it's a logarithmic scale. And on the other side, there is again a logarithmic scale of world capacity for sequencing DNA, and it's in base pairs. So just for illustration, the first point here is one terabase pairs, petabase pairs, exabytes pairs, and zettabyte pairs. So I guess it's clear from this that this is really big data. Again, like just to see like some kind of description, 2 points here are pretty like small number of genomes. It's like TCGA is I think around, actually 1,000 genomes is around 3,000 or 4,000 samples by now. TCGA I think is 15K, and whole exome exac is around 60K samples, if I'm not mistaken. Again, these three lines here, the blue line is actually Moore's law. You're all familiar with Moore's law, which predicts that technology moves at a pace that doubles every 18 months. The middle line, the yellow one, is actually an estimate from the industrial giant which produces sequencing technology, Illumina. And the red line, the topmost line, is actually the extrapolation based on historical data. So data is actually rising in volume much faster than we predicted. Okay, so just again for illustration, let's do just some kind of rough calculation. So one human genome is composed of some, let's say, 3 billion base pairs. So that's 3 gigabase pairs. 1 million human genomes is 3 petabase pairs, and 1 billion human genomes is 3 exabyte base pairs. And take into account that million genomes is a reality. So people are already trying to sequence million genomes. And again, rough calculation, we are gathering approximately 30 times more data per sequencing run, because there is like additional coverage and additional information. And if you take some kind of trivial encoding where you encode, because alphabet is 4 letters, you divide by 4, it's around 22.5 petabytes just of primary data for million genomes. In reality, this is even more. As far as I know, the last number I read is 100 petabytes of data only by 20 top institutions in the world. So it is a lot of data. And also one important thing for this slide, you can imagine that how number of, the volume of data rises steadily. You can imagine the price actually going down really rapidly. So right now, the $1,000 genome is a reality. It's already there. Okay. The last question for this introduction is, how do we do it? But this is not a description of the platform and a business pitch. I'm just going to show some kind of a diagram we made for this platform, so you can get the bigger picture of what actually goes into this into a platform of this size. So this is there are no real relations, communication channels, or something like that. And besides this compute and data platforms that you need to cover to actually do some kind of processing, into a platform goes a lot more than that. So you need to have some kind of user and management and billing management and permissions, and laws are very strict regarding that. So you need to be really, you really need to care about that. We also have a public API because not everybody wants to use the UI. You need to support numerous external authentication services, and at the same time you need to provide some kind of like a platform beside platforms which is used for all kinds of auditing and monitoring and instrumentation and so on and so on. So it's a pretty complicated platform. That's why we developed it for the last 6 years. So let's move on. So a slight intermission for this. Because from my perspective, because I'm here for more than 4 years, it is really too much change that happened in those 4 years, and it's really hard to actually fit it into a slot of 45 minutes. So I organized this presentation into 2 parts. So the first part, I'm going just to act like a historian for the platform and show you where we started, how we did things, what we built, and I'm going to probably concentrate only on bad thing. I'm not going to tell what's actually bad. I'm going to leave that to you to ask yourself, like, what the hell are you guys doing? And then after I finish that one, I will show what is the current state of the platform and the processes at SevenBridges, and I'll then switch to the lessons learned in the last part of the presentation. So lessons learned is also split into 2 parts. The first part is like technical lessons learned, which are related to technology, and the other one is management part, which I learned for the last 2 years. So let's move on. Okay, so before like this one, there is also a period of SevenBridges between 2009 and 2012. I can't really talk much about that. It's part of folklore right now in SevenBridges. You just hear people talking about that, like having people logged into a server machine while Igor or Denis does a demo there and hope nothing breaks. And it's not really a platform, it's a single machine that does some kind of calculation. So enter 2012. I joined SevenBridges as a platform engineer. I was supposed to work on the part of the platform we called the front end, but which was basically a Django application. And let's just go through the list. We are like maybe some 20 people in Belgrade, 20 to 30. We have no kind of organization. We're completely flat. We talk among each other. We pretty much know each other's code. It's around 10 services or so, and maybe some additional infrastructure tools. The way we do QA is mostly manual, so we have spreadsheets and we go through the spreadsheet and just tick the things that we tested. But it works. So we also don't have any kind of like methodology to say like we're using service-oriented architecture. We're slowly moving there, but it's basically like just make it work, make it work. For the integration, we have a single integration environment, because when you have 20 developers, everybody just can commit what the hell they want. We also have monolithic repositories, so when I commit and break something, I can fix it right away. And because it's mostly Java code, we see statically in the same repository that something broke, we can fix it and just push it, and everything's fine again. So regarding monitoring and stuff, we have no kind of application monitoring. We have infrastructure monitoring, so we know when a server dies, but we have no idea what happens on the service itself. We usually find out because somebody calls you on the phone and tells the application is dead. We have weekly or bi-weekly deploys, because we can. We have almost no clients, like those are individuals. They're using the platform, they're playing with the platform. Some clients are actually paying for the platform, but people are still like exploring what are the possibilities there. And as I said, we were a flat organization, but we had a director of engineering who acted as a senior developer in the organization. So what's next? It was good. Like when you have a small collective, it's pretty much still a startup. You feel like it's a startup, and people just enjoy hanging around the company, working there. We also have an anecdote where people wanted to sleep at the company, and then Igor bought some really, really embarrassing sheets, but people still slept with them, so yeah, weird kind of guys. So what happens next? Like, one of the first things that we wanted to improve on this, because we wanted to be like a serious organization, was the QA. And how we did it? Well, we figured out that we should automate more, like all of you know, we should. And we just figured out a way to actually write Selenium tests via Python framework, which was developed in-house. So we planned everything, we hired the guy, and the guy sits for a few months and puts it out there, and we still use it. So that's like an example of a minor improvement we wanted to make, just to make things like moving much faster. So next. So somewhere in 2013, we start talking about improving some other aspects of the platform, and we form a small team of 3 engineers, including myself. And we are frequently talking about how billing actually needs an overhaul. And what do? We start talking with stakeholders, but we didn't call them stakeholders then, we just called them Aca and Bojan. But basically, we start talking about requirements, what should a system like this do? It was basically a combination of a Ruby application and some kind of cron jobs and other scripts, which takes aggregated logs and parses data. And it broke sometimes, and it worked the other times, but it was like a good choice for like an overhaul. And because there is a tradition at SevenBridges now that started with some senior engineers, when you join SevenBridges, you need to name your service by something from the Harry Potter universe. So for those that don't know, Gringotts is the bank in Harry Potter. And so what do? This one. So we pretty much talk with the guys around the company. We figure out what needs to be done, besides charging for tasks, which boils down to charging for instances in the cloud. We also should charge storage. And storage is charged by parsing logs. And this kind of, in the retrospective, starts to stink a bit. The other thing, I won't say bad thing, the other thing that we also encountered was that we also figured out that we're going to also need a front end for this kind of application. So we're planning for that as well. We're exploring technologies which could solve that kind of problem, and somehow we ended up with Play and used Play. We figured out that the integration itself won't be so painful because we have a couple of services, and we communicate via HTTP APIs. HTTP APIs. But we know that maybe some kind of service needs to be shut down and move it to Gringotts, and also we need to take part of our monolithic application and move it to Gringotts as well. But we're not really alarmed, we're still excited. We want to like start working on this as soon as possible. So our first estimate for this kind of system is 1.5 months, which is really ambitious, but we believe we can do it. But some things start happening. We're a team of 3 people, and there are other projects happening at the company at the same time, and people get pulled from that project to other projects to work on something that shouldn't take too much, but in reality it takes 3 weeks. So we basically had a team of 2 people working on that because somebody is always out there. We also don't have to deploy anything because we're developing new stuff. And we have no visibility in the company of what are we actually working on. We have no demos, we have no integration environment in the first month or 2, so nobody actually knows what are we working on. And because again, we're not deploying, we don't have any pressure of sprints, which is really something we should have thought of. And so, you heard everything about Gringotts, but that wasn't enough for us. We suddenly decided we're going to split our monolithic repository of code to numerous repositories for all the components. And we start doing that. And when that happens, we actually break our integration environment because you no longer can deploy anything there. And only dark DevOps magic actually brought back the integration environment after a month or so. We also managed to break our own development environments, which we called views, but at least we actually didn't estimate anything well, so we had like a lot of work to do, which we weren't sitting idly. And at the end, we actually figure out that the data that needs to be used by this service is not really central. It's scattered across different services and databases and logs and files and so on and so on. So we need a migration. And we're just thinking, okay, migration, that's an easy thing. We're just going to make something work. We're going to call some APIs because we need some we need to call some business logic as well. And we make migration work, and it works for kind of 30-something hours. And this is unacceptable for production. So we try to optimize stuff, we move things around, and we boil it down to around an hour. And DevOps team says, okay, that's okay, an hour is acceptable for us. And we run it on production, and it lasts for 3 hours. So I said that we had an estimate for a month and a half, and this lasted for 6 months. And this is not listening to me. In the end, what this actually boils down to is a cluster duck. We actually didn't know what to do with this. Like, we had a system in production, it worked, but it definitely didn't satisfy all the business needs and all this that was defined by the specification. So I guess right now you're probably asking yourself, like, you don't know what are you doing? Like, are you sure you're software engineers? Okay, so that's the first case study. (2013, 2014). Like, we grew a bit, let's say doubled, around 50 or 60 people. We still have flat organization, but communication is a bit tricky. We slowly start figuring out that we don't know everything in our code base. There are around 20 or so services, so it also grew with the number of developers. Again, improvement on QA. We have now automatic and manual QA. And we now already have multiple integrations, so no single integration point because it started breaking too often. We now have separate environments per feature or per developer or however you want to develop, but it's completely isolated. And again, granular repositories, which were the product of doing it during the development of Gringotts. Like, this is standard, pretty much weekly deploy, but a number of clients is actually rising. And it's not only individuals, it's like small laboratories or people that actually need to process data on some kind of industrial scale. So no single task, like dozens of tasks or hundreds of tasks. We are also like flat organization, as I said. We have director of engineering, but we slowly start isolating vertical product teams. Like, we want to have a set of people belonging to the same team, which can cover the single vertical that's, let's say, related to running tasks or transferring files and so on and so on. So we start pulling in front-end developers and QA developers, but it's just an idea. We don't have enough people then to actually make those teams. And we're slowly also pulling out product people to actually start developing product in Belgrade. One thing we also do as part of this effort is we slowly start to concentrate on APIs. Because we have a lot of services now, like 20, not a lot, but 20. We need to think about like APIs and breaking APIs and the backward and forward compatibility and so on. But still, it's nothing that we actually written on the paper. We're just thinking about it and talking about it. So I'm going to go back to the topic of cluster ducks, but I'm going to just first introduce what you can actually do on our platform, because it's important for the next project I'm going to explain. So SevenBridges platform is actually used for running some kind of bioinformatics tools in a cloud. Why do we do that? Well, reproducibility is something that's a hard problem. Actually, it was a hard problem in bioinformatics, and people actually ran these kinds of tools on their own machines or clusters in laboratories. But the way you do it, you usually write a script that puts your input files into a tool, produces some output, and then it can last like from minutes to days, let's say. But you need to be aware that your tool is done, or that your tool is actually failed, or something like that, so you can continue the analysis. And recognizing that kind of problems, we made something like this is a standard pipeline or workflow. So the way you do analysis, you define some kind of input nodes, you supply inputs, and every little node here, like the circle here, is actually a command line tool, and you connect them with relations, which is actually a data flow. And so we supply this to our customers. They make a pipeline, run tasks, get results. It's easy. And so what happened next? I said that reproducibility is actually like a tricky thing. And these tools are not really like written by software engineers. They are written by scientists. You can just go and read some kind of code they've written. Something is horrible, something is good. But there is like, that's just more the reason to actually wrap it into something that's responsive to failure. So there is no reproducibility. People can't share their methods, can't share their results, because if I take the analysis of one guy, I can't really reproducibly run it on my cluster. So we decide, SevenBridges and some other institutions, that we're going to develop our own standard for making workflows. Excuse me. Our legacy standard is actually Python-based, and it's pretty much Python functions. You write Python functions, which tells like how the tool actually needs to execute, what is the command line, and so on. But it's not portable, so we figure out some kind of standard which is JSON-based. And like JSON structure, you will just describe what are the command line arguments for that tool, what are the inputs, what are the outputs, and you can just move it around. And it's called Common Workflow Language, or for short, CWL. So I didn't find a picture of a logo of Genomics, which is the implementation of CWL for bioinformatics. But this is pretty much the project that we started pushing on the platform. So what do we need to do to actually do this? So we figured out that our own computational platform can't really run this kind of tools. Like protocol is completely different. Actually, the formats are completely different. Like, yeah, you end up running command line tools, but we can't really parse that kind of information. And also, the way we did tasks before is not really compatible on how it should behave now. And scheduler is also should behave differently, and so on and so on. So somehow, we end up with the decision to actually rewrite our own computational platform, to write it from scratch. And because it's not compatible with our legacy stack, we also decide, we bring a product decision that we're going to support two types of tasks, legacy tasks and CWL tasks. So, yeah, also because we have two types of tasks, we don't want to mix up all the new tasks, and we want to actually use only new tasks in the future. We also have new types of project. And when we have new types of project, we also get like a lot of problems with front-end teams, because now they need to actually rewrite their own front-end components, because again, the formats are not the same. So pretty much a big complication like for a new standard. But anyway, we decided we're going to do it, and we started working on that. And again, that's not enough. Bioinformatics people from our company start working with CWL and Genomics, and while we actually developed the thing, they figure out that CWL is not really that, actually Genomics is not that really powerful as our legacy Python-based framework was. So we are actually at the same time developing the platform, developing the formats, and also migrating the tools. And that sounds like a really similar story. This is just the other kind of migration. You need to migrate, like actually our bioinformatics people needed to migrate a bunch of Python code, like I'm not sure, maybe 200, 300 something tools to CWL based applications. And there is no such thing as automatic migration of these things. Like they did their best in the sense they wrote some tools that to help them, but in the end they actually needed to make it manually. So again, it's a cluster duck, but this time it's only a rabbit, not a duck. And you remember this little rabbit from Monty Python's Holy Grail. So in retrospect, you could like tell, okay, so you had two projects, and both like had so much like smells and like bad omens associated with them, and maybe we could actually recognize that. So is it a bunny or is it a duck? But pretty much this is the source of all our problems at that time. Like we made two really big projects, and we tried to make some kind of big bang integration with them. Okay, end of this section. So 2014, 2015, what's changed? Again, we grew a bit. Again, let's say we doubled, 70 to 100 people. We moved to another office because the previous one was too small for us. Number of services didn't actually double. We got like 10 more or something like that. We have flexible deploy, which in practice usually means once a week, Monday morning, modulo like the critical issues on production and so on. We get even more clients, and we make like a decision to actually make a team lead structure, because we have too many engineers and people. We want to actually isolate the functional units there. So we make a team lead structure. I get to lead my own team of 3 or 4 people at the time. And we also like introduce product people, and we start slowly moving toward like having front-end guys and QA into our teams. And with front-end we have a lot of success because we have a lot of front-end engineers, but with QA not so much because we have maybe 3 or 4 or 5 QA engineers at the time. And like we went through some really tricky projects, but we don't care, because what's actually important is that we got the Cancer Genomics Cloud. So for people that don't know what's Cancer Genomics Cloud, I'm first going to do an introduction with the next slide. And that's it. This is the reaction we got when we found out. So Cancer Cloud is actually like a big national project granted by the NCI and the US government. And it boils down to the platform, which is similar to SevenBridges platform, but for solving the question, like for curing cancer. Like it needs to be like the initial idea was to actually gather all the data from like US medical institutions and put it into one place, so researchers can go there and explore the data, collaborate on it, run some analysis, and so on and so on. So we got this deal. We're really happy, but we are still not sure what is actually awaiting us. Like we're happy now, but in 6 months, like we're not so happy, we're not smiling. But anyway, in practice, what this means for us? This means that besides having like additional features and making things on the platform, we also have like a mirror of our own platform, which is different enough, just to annoy us. In a sense, like we can have the same backend, but you don't have this part of the backend, but the front-end component is completely different. Like I have a different schema for files, I want to use that. So in 2014, 2015, we are like pushing this CGC platform all the time. And again, we make some mistakes, but it's a bit better. Like we don't make some cardinal mistakes, let's say so. We're still lacking some good engineering practices. I'm embarrassed to actually admit that. But for example, I never once mentioned any metrics or measuring or something like that. Oh, this is not important. So on the question of metrics, like we now have team lead structure, and when we meet up to actually discuss some kind of decision or technology, usually it boils down to opinions. And this is actually a good quote. Like, if we have data, let's look at the data. If all we have are opinions, let's go with mine. And it's really frustrating when I have to actually explain to other team leads why my opinion is better than theirs. So, and this doesn't work. This is really bad. But somewhere around that time, we start figuring out that we actually need to measure things because people trust numbers more than they trust people. So this is also a period where we actually start hitting our first bottlenecks because we are no longer using like our old legacy platform. We have a new one. Our scale really plummeted. Like, we couldn't really run hundreds of tasks like what we could before. We made the cardinal error of basing everything on a centralized architecture, which is bad because we're working with a distributed system. Also, first management bottlenecks appear. Like, teams start growing, and at that time, I'm slowly thinking of like forking myself. And what do you basically do when you can't really manage more than 4 or 5 people? You just split the team, put a different team lead, put an API between your two teams, and you're done. And it worked fine. Maybe this is the only good thing so far. So, what's next? 2015 to now. This is nothing really interesting, but it's nice to see like what happened. Like, we didn't double. We are maybe now around 170 people. I put 180, like, which is like the number of people who should join. We have around 40, I think 45 services. We have more platforms which are made for different clients. Our QA also improved a lot. We have regression plus integration tests, which are included in the standard process of development. And finally, we have data-driven decisions. Like, we need to present data when we want to actually push something. And this is probably one of the most important graphs and one of the simplest graphs that I've ever seen. And this is from the Netflix presentation. It's a pretty old presentation, a few years old. And it shows the availability of software platform or software generally versus the rate of change. So horizontal axis is some abstract rate of change, and vertical is availability in this case in like .9s. So, and basically it's trivial. Like, if you have no change in the system, like you have large stability and availability, the more change you introduce, your platform starts failing, and you can't really control that. And what they argue in this presentation, and I recommend you actually watch it, is that you should strive to actually moving this graph toward like the upper right corner. Like, you need to have ways to introduce change controllably into the system, but not actually to lower down the availability of your platform. So, yeah, this is one of the best graphs. Okay, so this is the conclusion part of the presentation. What we actually learned. So, I just have to say, like, this doesn't have to work for you. Like, this is something that's, I would argue, unique for SevenBridges, because not all organizations are the same. But here are some, like, maybe 10 lessons or so. So, lesson number 1 is rewrite never. It's a bit controversial, again. Like, I'm actually telling you not to rewrite your software. And there is an asterisk which says, unless you absolutely have to, then think again. Like rewrites are really painful, and they usually, even if you have like all the things in place, like APIs which are backward compatible, you just need to put your new component there. It can be really painful because systems just don't behave that way. Like you can't really just pull a part out and pull a part in, especially if it's a big system and expect it to work right away. So never rewrite. Lesson number 2, which is a consequence of the lesson number 1. Iteration is your friend. Like this is one of the main lessons we learned while developing like these big components like Gringotts and Radix and so on. Like I usually hear like people telling me like we can't really do iterative development. Iterative development is hard. I can't deploy just a small part, but I actually think that it's doable. It's just harder, and people don't want to do it. There is a valid concern as well, which boils down to my product actually doesn't allow to do it. Like my product is like one whole. I need to put it that way, but I would argue that you can refactor the product as well and then push it one small unit at a time. Lesson number 3. Everything is constantly evolving, so should you. So this is pretty important because like we're talking about systems that are constantly changing, like, and we often forget that you actually can't just put a new part into the system and not affect the rest of the system. So we think like I'm going to just add a new client to this API and it's going to ping my service for, I don't know, every 10 seconds. It's not going to affect anything. But in reality, it can like put the machine down if you just are that unlucky. So we should always like test as much as possible and see what happens when we try to switch parts or move parts around, especially in a system with too many moving parts. So next lesson, know the machine. This is also important and is related to metrics and measuring stuff because especially in this age of like containers and the paradigm that shouldn't be named, microservices and everything, we have a lot of abstraction and we have a lot of like magic happening around. And I would argue as well that it is really important to know the machine even under those circumstances, because either way you're going to end up on a physical machine which has physical limits, and you need to know what are you actually doing. Lesson number 5, avoid engineering porn. Again, this is related to a problem that we experienced numerous times now, where engineers are actually concentrating on their solutions instead of concentrating on the problems they're trying to solve. And when you concentrate on a solution, you end up figuring out what's the newest shiny framework I can use to actually solve this, what is the newest database in alpha 0.0.1 version I can use there, and so on and so on. But forget that there is an actual product in front of your system that solves some real problems. Lesson number 6, minimize human error or strive toward idiot-proof systems. This is important because you can read all over the internet and in books as well that the most common reason systems fail catastrophically is human error. And in most cases, it's actually a misconfiguration issue. So if you can make a system that actually makes these kind of errors not impossible, because it's not really possible to do that, but at least minimize them. A good technology stack will take you far, and there is also an asterisk there. So we decided to actually develop our own technology stack. We're not into some kind of enterprise containers, and yeah, okay, I need to probably to wrap it up fast, but let's go through this. So other lessons I have here were give freedom, expect responsibility, which is related to agile teams and giving engineers the freedom to actually experiment with new technologies, but also getting the responsibility which comes with that. The other thing is culture related, and it's ask and be kind. Like there is that, I can't really tell what's the rule for that. but you always need to be kind, and if you don't know something, please ask, and if you know something, please tell. And the most important lesson probably is that delay makes hard decisions harder. So you need to be a tiebreaker from time to time and to actually bring a decision for which somebody will probably hate you. But never mind. And the most important thing is just ship it. Okay, sorry, I went over my time. I'm going to open for Q&A if somebody has any questions. Okay, I'll be around if somebody wants to talk, because we need to wrap it up. Thank you.